So today's topic will be credit cards and Oracle E-Business Suite, and specifically what we'll be talking about is security and compliance issues related to PCI. And we'll start off talking about PCI in some detail, and then talk about Oracle E-Business Suite and how to be PCI compliant within your Oracle E-Business Suite environment. So we'll kind of take it a couple of different layers and try to go through and kind of build up and discuss some of the issues and then some basic solutions. So we'll start off with a PCI overview and then talk about Oracle E-Business Suite and how it relates to PCI DSS. Then we'll talk about specifically some solutions and how you need to implement and satisfy some of the requirements within PCI. First and foremost being encrypting the credit card data. And then second, there's a number of PCI requirements that are fairly difficult to implement within the Oracle E-Business Suite, and we'll kind of discuss those in some detail. And then we'll finally open it up to answer some questions at the end. For those of you not familiar with Integrigy, I'll give you a quick background. Integrigy was founded in 2001, and we specialize in Oracle security, both on the Oracle E-Business Suite side and the database. Integrigy actually has two sides to our business. One, we do have some products, first being App Sentry, which helps to automate the security by scanning your environment, determining what's wrong, if you have default passwords, that you're up to date on your critical patch updates. And we also have another product, App Defend, which we'll actually discuss a little bit in this presentation because it helps satisfy one of the PCI requirements. And it's an application firewall, so it helps protect Oracle E-Business Suite when you put it on the internet. And then on our services side, we do a lot of on-site security assessments, compliance assistance, so we'll work with a lot of customers on PCI compliance specifically. Integrigy is not a QSA, which is a PCI qualified security assessor, but we actually work with a lot of QSAs in helping customers become PCI compliant. So we kind of do pre and post audits. So we'll actually be hired by clients to actually come in and do an PCI compliance check on their E-Business Suite environment, which then feeds into their PCI compliance overall. And then we'll also help with different security design solutions, auditing, and things like that. So this is an educational webinar, so I won't talk anything more about Integrigy or our products, and really just talk about PCI compliance and what you need to do for your Oracle E-Business Suite environment. So let's start off with the PCI overview, so everyone's kind of up to speed on PCI. So whenever you talk about credit cards, PCI is the dominant compliance standard. And the question is, what is PCI? What happened a number of years ago was that the different credit card agencies, American Express, Discover, MasterCard, Visa, all had their own security requirements that they were pushing down to people accepting credit cards, which are referred to as merchants. So the merchants were saying, well, we're talking MasterCard, they have one set of standards, Visa has another, American Express has another, and they're kind of in conflict a little bit. Some of them say it should be this, some of them say it should be that. So the credit card brands actually got together and formed the PCI Security Standards Council to consolidate all the security requirements across all the credit card brands. And the PCI Security Standards Council published a document that's the data security standard. So this is a very specific requirement for merchants who are accepting credit cards on how they're supposed to do security. And then the other piece of what the PCI Standards Council does is it actually qualifies people to actually be a qualified security assessor. So if you're a large enough merchant and you accept over several million credit cards a day, or actually in a year, you actually have to have someone come on site and do a review of your environment, and that would be a qualified security assessor. And if you actually have e-commerce type systems, then you also need to have an approved scanning vendor, and that person will actually scan your external environment to make sure that there's no security vulnerabilities. So the PCI Security Standards Council manages both the standards and the list of assessors and consultants that actually can do compliance activities. So a little bit more about the data security standard. So the core of really PCI is the data security standard. So if anyone talks about PCI, they're really referring to this data security standard. That's really where the rubber meets the road. That's the definition of all the requirements to great level of detail. The best thing about PCI is it's very prescriptive. It tells you exactly what you need to be doing. And the worst thing about PCI is it's very prescriptive. It tells you exactly what you need to be doing. So there's 12 major categories, and we'll actually talk about some of these in great detail. And then each category is broken out to sub-requirements, and there's about 200 specific sub-requirements. So it does go to a fairly granular level of detail, and it says, well, your password length has to be 7 or greater. And so it's, in some areas it's very detailed, other areas it's somewhat vague. And a qualified security assessor can help a lot of different questions. If you do have a overarching question on what should be done, a lot of our clients actually hire a qualified security assessor to actually assist them with the compliance effort before they actually have to do a report on compliance. And really the data security standard is focused solely on protecting credit card data. It's pretty good in terms of general IT security controls, and so it's what you should be doing anyways, but really all it cares about is that your credit card data is secured at the end of the day, that someone can't hack in and steal the credit card numbers. If the rest of your environment's not working so well, it doesn't really care. It just cares for those systems that have credit card data that they're doing the right thing, and they're hopefully putting in a layer of security. All the requirements are mandatory, and if you do have a mitigating control, since you can't meet one of the requirements, PCI is very specific on what a mitigating control can be and can't be. It has to be greater than the requirement. You just can't say, well, we need an exception on this one requirement because we can't satisfy it. PCI doesn't accept that. It says, well, your mitigating control has to be above and beyond what the standard control says. So to get a little bit more detail on how PCI actually works is there's a standards council. They've developed a data security standard. And then there's a number of sub-procedures and things that are related to that. So as part of auditing, so when a qualified security assessor comes on site, they actually have detailed audit procedures. You can go to the PCI Security Standards Council website and actually download all these documents. And so you can see specifically what the QSA will look for. Then there's scanning requirements. So when an approved scanning vendor is going to scan your external environment, they have very specific requirements, and those are all well documented. You can actually download those documents and read them. And then probably for a lot of the people on this call today, you'll be required to actually do a self-assessment questionnaire, the SAQ, versus actually having someone on site. And that's purely based on how many transactions you do a year for each credit card brand. And then what happens is you're not actually returning anything back to the PCI Security Standards Council. You actually have to return these documents to either American Express or a bank that's processing your MasterCard and Visa credit cards. And so it's kind of a funky little structure the way it works, but typically when you're dealing with MasterCard and Visa, the person applying the pressure for PCI compliance is actually going to be what's called the acquiring bank. So that is the organization that's processing your credit cards. So if you, a very common one for Oracle Business Suite environments is Chase Payment Tech. So Chase Payment Tech would be the actual organization mandating that you're doing PCI compliance. So PCI compliance is really dependent on the card brand, the merchant if you're doing e-commerce. And so then what happens is it requires you to do on-site security assessments or self-assessments, and then potentially also quarterly external scans. So our external scan is you give the approved scanning vendor all your external IP addresses, and they run some tools and make sure that they can't find any known vulnerabilities on any of the servers in that range of IP addresses. One of the hidden kind of subtopics of PCI is you can do a lot of work right now and be fully PCI compliant, do everything you're supposed to, but truly PCI compliance is only assessed in one case, and that's if you have a data breach. So no matter what you do before your data breach really doesn't matter. Yes, you will get fined, and credit card brands will say they won't accept you anymore and things like that. So there's bad things that can happen. But the key is when if you do have a data breach, what will happen is a forensic audit team will come in and fully review where you were with your PCI compliance at the time of breach, and if your PCI non-compliance was instrumental in that breach. Therefore, then you'll be deemed out of compliance at that time. So PCI, even though you're doing your on-site assessments, your quarterly scans, and things like that, you always have to keep in mind, in case of a data breach, is really when PCI compliance is fully and very deeply assessed. So a lot of people say, oh, we passed off on our self-assessment questionnaire. Well, is everything truly in compliance? And if you do have a breach, there's going to be a forensic audit team coming in, and what they're looking to do is establish liability. So if you were out of compliance with PCI at the time of the breach, even though you had a fully incredible report on compliance from your on-site assessment, it's really what that forensic audit team found. And if you were not in compliance, and most likely you weren't in compliance when you had your breach because you had a data breach, that determines liability. So that's always a kind of a key caveat. So you always have to keep that in the back of your mind is, yeah, somebody's going to come in and go through this in great detail for weeks at a time, trying to figure out exactly what went wrong and why you were out of compliance, even though you're doing all the paperwork and getting lots of green check boxes. So in terms of PCI compliance, there's a number of levels. So these are the levels for Visa and MasterCard. American Express is a little bit different. So if you're a very large merchant like Amazon doing 6 million transactions a year, there's one set of requirements. If you're a small vendor, and typically the red arrows there indicate for most Oracle Business Suite environments that process credit cards, typically they're level 3 and 4 merchants. They're not processing millions and millions of credit cards through the Oracle Business Suite. So the requirements of what you have to do to achieve compliance is slightly different. But fundamentally, for the PCI DSS requirements, every single requirement is mandatory for every single merchant level. So even if you're just processing 10,000 credit cards a year in your Oracle Business Suite environment, your environment has to reach the same level of compliance as Amazon. There's no just, oh, we have to encrypt credit card number data and the rest is optional. No, every single requirement has to be satisfied by every merchant. And that's kind of the key thing to think about. So if you've got a large Oracle Business Suite environment that's running HR, manufacturing, everything else, and you're just processing some credit card numbers for maybe a parts division that's kind of doing parts, but you're not really selling your main product through the web Oracle Business Suite and accepting credit cards, but you're maybe doing 10,000 part orders a year, your entire Oracle Business Suite, including your HR system, has to be PCI DSS compliant. Now, we've actually had some of our clients pull credit card processing from the e-business suite, put it into a separate system because it was so hard to achieve PCI DSS compliant for the entire environment. So that's kind of something to keep in mind. So that's kind of a brief overview of PCI DSS. Just wanted to give you a little history of where it's coming from and some of the key aspects of the overall program called PCI. So let's talk about PCI DSS and e-business suite specifically. What are some of the things you need to keep in mind before we talk about specifically what you need to do to achieve PCI compliance? One of the questions we always get is, do we have to be PCI DSS compliant? And the definition of PCI DSS compliance scope is very specific. If any system stores, processes, or transmits credit card data, it must be PCI DSS compliant. So if you're just storing a credit card number in the database, even if you're just processing it, so it may be just flowing through and you may be using iPayment, and for some great customization, you're not even storing the credit card number. If this credit card number flows through Oracle Business Suite at all, it has to be PCI DSS compliant. So this is a very specific requirement. So any system that sees credit card data has to be in the scope of compliance. And within the scope of compliance requires network segmentation and a lot of work, including encrypting the credit card numbers. And this is regardless of size or transaction volume. There's no requirement to say, well, if we're only doing 10,000, we don't really have to do a lot of the requirements. No, all 12 categories have to be satisfied, even if you're doing 10,000 credit card numbers versus 6 million. Well, we get a lot of questions on that, a lot of pushback, but that's the way PCI DSS works, and it's pretty well documented and stringent on what they require and not require. So let's get into the kind of the high-level categories at first. And what I've done here is map out the PCI DSS major requirements, 1 through 12, and then looked at different parts of the technology stack. So from the network, server, database, Oracle Business Suite perspective, and then policies and procedures. And the checkboxes show which of the specific requirements have to be achieved for those different levels. So for the Oracle database, requirements 2, 3, 6 through 11 basically have to be achieved. So, and then for the Oracle Business Suite, you're looking at the same. So mostly policies and procedures can be fairly generic for the organization and don't really have to be an Oracle database specific policy. But when we talk about securing credit card data, number 3, you have to be encrypting the credit card numbers in the database. So you have to do something there. And so now if we take it to the next step, and what we actually did was went through the major sub-requirements here and then mapped it to level of effort. So some of the things are a little bit easier to achieve than others. Some are very, very difficult. So we kind of rated high, medium, low. Typically low would be the DBA would have to go in and do something, kind of set some settings, pretty easy, not a lot of testing required. Medium would be, well, I probably want to put it in my test and development environment for a while, make sure it works. It might take the DBA a couple hours to actually maybe apply a patch, do some testing, do a little bit of reading on MetaLink, things like that. High is what we'd kind of consider maybe even a sub-project. So in terms of, let's say, number 10, track and monitor access, to set up logging at both the Oracle database and the eBusiness Suite level is a significant project. You need to put the logging somewhere. So you actually might have to implement an entire logging solution to actually get the logging data and audit data out of the Oracle eBusiness Suite. So number 3, protecting credit card data. So you actually have to apply credit card encryption patches potentially to your 11i environment. You have to enable it. You have to do significant testing. You probably have to do some searches for credit card data in the environment. So some of these are almost sub-projects. They might take someone 2 or 3 days. In some cases, this might take 2 or 3 weeks worth of effort. So PCI compliance is not a minor. It's just not, okay, flip the switch. There's not an initialization parameter, PCI DSS compliance equals true. There's nothing like that. This is actually a fairly significant level of effort, and Oracle eBusiness Suite is not compliant out of the box. So a lot of questions always come up about, well, Oracle must have solved this problem, right? So when you install it, it's compliant. The standard installation is not compliant. It requires a lot of significant effort to get Oracle eBusiness Suite up to PCI DSS compliance. Some of these are actually sub-projects. That's going to take a couple hundred hours of time overall to actually get it fully compliant. Out of the box, credit card numbers are stored throughout the Oracle eBusiness Suite. It's stored in multiple tables if you're using a lot of modules. They're stored unencrypted. There's not much masking. iPayment, the default configuration of iPayment, you think that would be the one piece that would be PCI DSS compliant out of the box, is not. So there's actually some setup and configuration changes you have to make to the one module that should be PCI DSS compliant, but it's not out of the box. So there is a significant amount of work. So everyone who's running credit card numbers in your Oracle eBusiness Suite environment, there is a significant amount of work, and Oracle has not done it for you. So in general, with the Oracle eBusiness Suite, there is some good news. The first is there's a number of bad things that you can be doing with PCI DSS. So there's things that PCI DSS says absolutely should be verboten, should never be done. And the first is when you have your credit card number, everyone here has probably bought something online, you've got the 16 digits on the front of your Visa card, but then when you flip it over, you've got those 3 digits on the back, or for your American Express card, it's those 4 digits in the upper left of the front of the card, or it might be on the upper right. So that's called the CVV code, and it has different names. So it's CVV, CV2, CID. Each credit card brand calls it something different. In the Oracle eBusiness Suite environment, fortunately, that number is not stored. It may be temporarily stored if you can't process a transaction, but according to PCI DSS, you should never store that CVV code or the magnetic stripe data. Fortunately, most Oracle eBusiness Suite environments don't even deal with magnetic stripe data because that's dealt with another system. I don't know of any supported solution that lets you swipe credit card numbers from the card and actually get it right into Oracle eBusiness Suite. Typically, it just sends the credit card number, not the actual data on the card. So that information should never be stored. If you ever see it stored, that is a major red flag. You should bring it up and immediately work to get rid of that. The second part is credit card numbers should never be stored unencrypted. Oracle does store them unencrypted by default, and we'll talk about how to fix that. And then generally weak IT controls, so passwords, patching, management, development, all should have at least strong controls around them. And that's usually from an organizational perspective, not just an Oracle eBusiness Suite environment. And then there's another aspect of PCI. So we've talked about PCI DSS. There's also something called Payment Application DSS. So the PCI Security Standards Council is actually working now to say, well, if you have an application that's off the shelf, like Oracle eBusiness Suite, it's a package application, well, it should be certified to accept credit card numbers. And so there's a whole other security standard called PA, Payment Application Data Security Standard. And so now the PCI Security Council wants everyone to actually submit their applications for certification, pay an external party to actually certify that your application is meeting the PCI DSS compliance requirements. Oracle says it is PA-DSS compliant for 12.1. Unfortunately, they are not on the list. So if we actually go through, and let me switch out here, and we'll actually show you, if you go out to the PCI Security Standards website, I'll blow it up a little bit here. So there's actually a validated payment applications web page, and you can actually then see what applications are out there. So I just searched Oracle here, and Oracle e-Business Suite is not on the list. I don't have an answer back from Oracle. I've tried to ask what's going on, and they have refused to answer our questions regarding the topic. But the Oracle retail package is certified, but not Oracle e-Business Suite. So that's kind of an interesting dilemma for a lot of customers because they are expecting Oracle to be providing that level of compliance, and Oracle has not done that yet. So if that does come up as an issue, you need to be thinking about what the answer is, and probably opening a support ticket with Oracle to get that resolved. So there is a MetaLink note out there that is about 12.1. So Oracle's gone through PA-DSS and tried to do everything within the application. What they have said for sure that 11i and 12.0 will never be PA-DSS. So if they are achieving certification for 12.1, it's going to be 12.1.3 only. And so if you are running an older version, you'd have to upgrade in order to achieve PA-DSS compliance. The fortunate thing right now is we aren't seeing many customers being forced to be running certified payment applications. Visa and MasterCard really are not enforcing this requirement at this point, even though I believe it took effect last year when they were supposed to. They are giving a lot of people leniency on this because there's not a lot of PA-DSS certified applications, and as you know, it would be a fairly traumatic thing to have to upgrade or change your vendor just on PA-DSS certification. So another aspect of PCI DSS is the prioritized approach. So when you're actually trying to achieve PCI DSS certification for your environment, you can actually do a prioritized approach. And this is accepted by most of the acquiring banks at this point because they just want you to at least get started moving down the road to achieving full PCI DSS compliance. They know no one can do it just at the drop of a hat. It's a significant project to get fully PCI DSS certified. So what they are doing is mandating, okay, let's go 1 through 6, 1 being the things that you have to do immediately, and then they've gone through each requirement and said, well, this is milestone 1 through 6, with 1 being the most important, 2 being next, etc. And so if you kind of go through the prioritized approach, I summarized this again on the Security Standards website. They have a very detailed Excel spreadsheet that has every requirement at the level. But basically the first thing they want you to do is get rid of your CVV numbers, your magnetic stripe data out of the environment. So hopefully for all Oracle e-Business Suite environments, that's not a problem. Number 2 is a secure configuration. They want you to at least be changing the default passwords, getting things secured. Number 3, and we'll talk about this later, is putting in a web application firewall that you're protecting your external environments. 3 is that you're applying your security patches within 30 days. And then 4 is access control, making sure that everyone has assigned ID, they don't have weak passwords, that you're doing logging and monitoring for forensics capabilities. And then what's very interesting on PCI DSS prioritized approach is number 5, one of the last milestones, is actually then encrypting credit card data. Fortunately for e-Business Suite, encrypting credit card data can be one of the first things you can do fairly quickly and easily. But this is kind of the prioritized approach. So when you're approaching PCI DSS and you're thinking, well, this is just a massive amount of undertaking, we can't get everything done right now, the best thing to do is start going through the PCI DSS prioritized approach, looking at each level and say, okay, what can we do for the milestones 1, and trying to at least bite off chunks and move forward and get through probably level 3 in terms of the milestones pretty quickly, because then when you start looking at 4, 5, and 6, those are the things that take a lot more effort, like establishing logging and monitoring, which means you have to put an enterprise logging solution in place. That takes a lot more time. But doing a secure configuration, starting to get security patches up to date actually can be done pretty quickly. So that's kind of a little bit of background on e-Business Suite and PCI DSS. Now let's go through some of the key requirements and how to achieve those. And the first and foremost in the PCI model is really encrypting credit card data. Fortunately, Oracle's got a solution for this. And so it was about 4 years ago, Oracle came out with a solution. And the key thing for Oracle e-Business Suite is what they had to do was go through every single place that touches credit card data in the application, all forms, all web pages, all concurrent manager programs, all reports, and put in extra code to encrypt and decrypt that data when it was being read and written. This is an application level encryption, so whenever the application reads or writes the credit card data, it's actually encrypting it and decrypting it. Fortunately, this is a much, much better solution than anything provided by like transparent data encryption. Oracle Transparent Data Encryption only encrypts and decrypts the data when it's written to disk. So if you actually log in the database, you can actually see everything unencrypted, but if you did lose a disk drive, lose a backup tape, or someone stole one of your database files, the data is fully encrypted. But once you have a database session and you have access to that table, you can fully read the data. The Oracle Business Suite encryption for credit card numbers is at the application level, so unless you can get into the apps account, you can't read or write the data. You see just basically encrypted values, and it's a little bit difficult to actually unencrypt them. They're using a pretty good encryption in terms of triple DES. If you're in R12, the credit card encryption is already there, and if you're on 11i, you actually need to apply a patch. So for 11.5.10.2 environments is pretty much what's required. There's a patch out there that you have to apply. As part of R12, the patch is there by default, but it is not enabled. So even if you're running 12.1.3, great brand fresh install, credit card numbers are not encrypted. And so what they've done is for the patch is actually implement a fairly robust encryption scheme. And so they're implementing the FND Vault. So there are some database packages and things out there called FND Vault. And that is actually storing the credit card encryption keys within the applications securely. And then what they do is they're actually consolidating all the credit card numbers into a single table. And so then also anytime they've ever read or write the data in the application, they're actually calling packages to encrypt and decrypt that number. And then they're doing a fairly sophisticated level of additional features to allow quick searching and matching of credit card numbers. Because if your number is encrypted and you try to search for somewhere for a credit card number, you would have to decrypt every credit card number. So what they do is they not only store encrypted credit card numbers in the IBUI security segments table, they're actually storing hashes, and a hash allows a very fast lookup. So if they want to look up a credit card number, they can actually do it very fast. So the performance overhead's not that great of this encryption patch. So to kind of show you graphically what they've done is, so if you implemented credit cards in a number of modules, so if you had Oracle Service, Oracle Order Management, AR, and you were just using credit cards in a lot of different modules, what was happening is those credit card numbers were being stored by module in different tables. So a very common one is OE Order Headers All table. And so there's credit card numbers in that table. This became very difficult to manage. So you've got credit cards all over. They would have to do significant code rewrites to actually process and change it. So as part of the credit card encryption enablement process, so when you enable encryption, you go in and actually do some settings, and then you have to run a bunch of concurrent manager programs. What the concurrent manager programs do is actually take the credit card numbers that may be existing in the environment for an existing install and actually move them into a single table, IBUI security segments table. And so what it's doing is actually then replacing what was like an OE Order Headers All table and actually putting a token there that points back to IBUI security segments. So the fortunate thing is after the credit card encryption patch is enabled, all your credit cards end up in one table, IBUI security segments, which is very beneficial to have it in one place. So you can actually do a little bit better security, you can manage it a little bit easier. So that's basically what the credit card encryption patch is doing. You run concurrent manager programs and it actually moves all that data. One of the things you do have to think about is after you run those concurrent manager programs, we found a number of issues with that not all the credit card numbers were moved. So it does take a little bit of manual effort after the fact, we believe, to actually verify that everything worked. And that is not part of the Oracle documentation. So after you run the concurrent manager programs, go through the tables that you believe there were credit card numbers and actually search on those columns and verify all the credit card numbers have been removed and replaced with tokens. And pretty much you can check that pretty quickly because credit card numbers are either 15 or 16 characters in length. So American Express card number is 15 characters. And Visa or MasterCard is 16 characters. So you can actually check to see if there's anything of length 15 or 16. The tokens are longer than that. So it's fairly easy to check, but that's not in the standard documentation. And we found a number of maybe 30 or 40% of the customers who think they've done it right. We've actually found some remaining credit card numbers in the tables. That it either errors out attempting to move them or something else goes wrong that not every single card number is moved. So that is one thing to check. So that's how the standard Oracle E-Business Suite credit card encryption works. So they've done a fairly good job about taking care of the Oracle data. But what happens is, a lot of times that we found is credit card data actually ends up being in other tables too. So the PCI DSS security standard is encrypt credit card numbers wherever they are. So you may be accepting credit cards through a third-party e-commerce system using an interface or custom table to actually store those credit card numbers before they're processed in iPayment. So you do need to think about your customizations and if you're storing any credit card data in custom tables. Another thing we find often is maintenance tables. So the classic example is Oracle tells the DBA to do a direct SQL statement update to a specific table, so they might have done OE order headers all or IBY security segments. And any competent DBA, the first thing they do is actually they create a backup table, so they do create table as select, and that will actually create a mirror table, and they typically give it a extension like the current date, just that they know it's there. Before they do the direct SQL update, in case anything goes wrong, they can put the table back. Unfortunately, then what happens is they tell the person who's supposed to test the patch, oh, go ahead and test the patch, make sure it worked, things like that. And they forget about the backup table. And then that just sits out there, and then that's full of credit card numbers. So when we go do our data searches through different environments as part of our consulting engagements, we look and find quite often mirror tables that have credit card data that's unencrypted, things like that have just been sitting around there for a number of years. Another area is interface tables. Interface tables are supposed to be temporary. So what you do is you run the interface, it populates the table. And in PCI DSS, most often assessors will accept this because it's only a transient table. You're putting data in there just for a few minutes to run the concurrent manager program, and it disappears. So that's usually fine, and that's usually acceptable for PCI DSS for an interface table when that happens, not to be encrypted. Unfortunately, what often happens is credit card numbers get stuck in there. So the interface, for some reason, blows up. Somebody reruns the file, but these records get stuck in that interface table and never get processed, and there's unencrypted credit card numbers in interface tables. So you have to be very aware of what tables are being used for interfaces for credit card numbers and make sure those are dealt with on a timely basis and that every record is processed. Another area is interface files. When you've got these interface files coming in, there may be a direct table update, or it may be a flat file that's coming in, and then you're using SQL Loader or something like that to get it in the interface file. Those files also have to be encrypted. Then another area is log files. So iPayment, you can turn on debugging for iPayment and actually write out all the credit card data to a log file. We had one case one time where they had iPayment debugging enabled, then they had an anonymous FTP server running, so they actually had the iPayment debug file on their internal network that could be accessed by anyone in their corporation. That was kind of interesting. Occasionally you'll find things in like flex fields. So we had one case where we did find credit card numbers in a flex field. For some reason they wanted it in there, and that's very hard to find. But you just have to be thinking about all these different locations where credit card data might exist, and it all has to be encrypted, or have a solution to make sure, like the interface tables, credit card data doesn't sit in there when it shouldn't. So it's kind of encrypting the credit card data at a high level. It's fairly easy to enable the patch. You just have to be aware that sometimes it doesn't work properly. You have to run the concurrent manager programs. But once that's enabled, that solves a huge requirement. So that's requirement 3.4 to encrypt your credit card data. And that's a major milestone and a major step to achieving PCI DSS compliance. And a lot of people think that's it. That's all they have to do is at least encrypt the credit card data. And unfortunately, all 12 requirements are mandatory. You have to be going through every single requirement, 200 sub-requirements, and make sure you achieve every single one. And now what I'll do is walk through some of those high-level requirements to just give you a brief overview of some of the challenges that you'll encounter trying to achieve PCI DSS compliance, especially for a large Oracle E-Business Suite environment. So the numbers I have here are basically for the requirement. So requirement number 2 is don't use any vendor-supplied defaults. And so basically this is just a hardening exercise of going through the Oracle E-Business Suite and changing everything you should change. And what PCI DSS wants you to do is have configuration standards. Have documented standards saying for all our Oracle databases, this is what we're doing. For all our Linux servers, this is what we're doing. Unfortunately, there is one also required for Oracle E-Business Suite, and you can actually use the Oracle's secure configuration guide for the Oracle E-Business Suite. Unfortunately, Integrigy wrote most of that document for Oracle, so it's actually a pretty good document. It hasn't been updated significantly. The last major update was 2007. It's only received minor updates since. But that should be your base. You should be going through that secure configuration guide and changing all the defaults. So all the default database passwords, all the seeded application accounts, things like OP-sysadmin. A lot of people don't realize that within the application there's an account called OP-sysadmin with the password OP-sysadmin. So why don't you go try in your Oracle Business Suite environment and see if you can log into that account. That password should have been changed and that account end dated. So those are the type of things that are part of the secure configuration guide. And finally, one that's a little tricky one. In terms of networking firewalls, there's a lot of requirements within PCI DSS. There's one requirement that's you would think is in PCI DSS for sure, but it's not. You do not have to encrypt credit cards on your internal network. So if you're sending credit cards unencrypted throughout your internal network, that's actually fine. That's within compliance. You do not have to encrypt the credit card numbers on the network internally unless it's wireless or if it's going outside the organization. So anything external has to be encrypted, anything wireless encrypted, but anything internal does not. There is one caveat about that that's kind of difficult in that all administrator traffic must be encrypted. And that's defined as anything that an administrator would be using that would have elevated privileges. So anytime the DBAs are signing into the operating system, they have to be using SSH. So they have to be using a secure protocol there. Whenever anyone's using any system administrator responsibility, they have to be signing into the application using a secure protocol like SSL. So even though your users don't have to use SSL, so that's when you type in the browser HTTP or HTTPS, the S stands for SSL for a secure connection, all your application traffic has to be encrypted using SSL because administrator traffic has to be encrypted. Another caveat is, so the DBAs are directly accessing the database as apps or sys, while their SQLnet connection should be encrypted. That is one of those type of requirements that kind of gets swept under the rug. It's very difficult to do SQLnet encryption. You need an advanced security option, which is a very expensive add-on. So in terms of most people that I see doing PCI DSS compliance, they kind of ignore that piece about using SQLnet encryption for DBA traffic. But as long as your DBAs are going in as SSH, your front end is encrypted as SSL, you should be fine. But if you ever got a really stickler person coming in saying, well, oh, the DBAs are connecting via non-secure because SQLnet is not encrypted by default and you need ASO to encrypt it. So that's kind of one of those interesting caveats. So as part of requirement 3 is basically protect credit card data. So the 3.4 is the major requirement there about encrypting it. And the key is you have to find where all the data is, make sure it's not in log files. And then 2 areas that are not supported by Oracle today and are really custom solutions. One is one of the requirements is, and it's not specifically stated how many months you have to keep, but generally it's accepted as you should only have 18 months of credit card data online. Because what PCI DSS wants is if your environment is compromised, you do not lose significant amounts of data. So they want to keep the minimum amount of data online. And the definition of minimum amount of data is in order to achieve either refunds or chargebacks. So if someone's allowed to charge back, so if you dispute something in your credit card, you're allowed to 12 months to do that from the date of the transaction. So you have to have that data online and available to basically reverse a transaction within 12 months. And so generally it's 18 months of data is required, but really nothing more because you can't do chargebacks, and unless your organization requires refunds over a 12-month period, most people don't really need credit card data. The one exception to this rule is if you're doing a recurring transaction, so you're charging the person every month, that data is allowed to be kept as long as that recurring transaction is occurring. But Oracle has no solution today for purging credit card numbers. You can purge the transactions, which will purge the card number, but most organizations do not allow purging of transactions, and typically it requires 3, 5, 7 years of data online. You don't have to purge the entire transaction in PCI DSS, you just have to purge the credit card number. And there is no Oracle-supported method. There's an enhancement request, but Oracle doesn't have any way to do that. So people implement custom solutions to deal with those, either purging out the credit card number, so you'll get an error if you try to bring it up after that time, or putting a dummy credit card number in. The second part is you have to scramble the credit card numbers if your cloning from production to test and development. There is no supported way to actually remove or scramble that real live data. Even if it's encrypted, it still has to be scrambled when you clone to test and development, and there's no supported way to do it. Again, a custom solution is required, a custom program to actually scramble that data when you're doing cloning. Another very difficult requirement to implement is basically 6.1, which requires security patches to be installed within 30 days. The requirement's very clear. Install critical security patches within 1 month of release. There is a caveat that you can do some risk-based patching, but specifically in the requirement it mentions while databases are a high-risk component, and if you're storing credit card numbers in a database, you need to be applying the Oracle Critical Patch Update within 30 days of release. Very few organizations can even possibly do that requirement, is apply it within 30 days. And so again, these are some of the requirements that are very difficult to achieve within PCI DSS. To get security patches within 30 days, that is very difficult. Another one is if you're running iSupply or iStore, iSupport, even if you're not accepting credit card numbers through that piece of the system, remember Oracle E-Business Suite is a very integrated application. So even if you're just running iSupplier, it has nothing to do with credit card numbers, but by the way, it connects us at the apps account, and if there's any problems in iSupplier, you can compromise the entire environment. So PCI DSS requires the external environment to be protected, and you either have to do an annual penetration test or have a web application firewall. Your organization may already have a web application firewall. Unfortunately, that's not optimized for Oracle E-Business Suite. Very few, if any, of the web application firewalls on the market have any kind of rules for Oracle E-Business Suite. In order to solve this problem, we actually wrote our own. So Integrigy has a web application firewall for E-Business Suite. It's specific to E-Business Suite. That's the only application we support today. But it satisfies this requirement 6.6 and also helps satisfy some of the other requirements in PCI DSS, specifically logging. The example there is one of the difficult things is you have to log all application access. Well, Oracle puts that in a table. How do you get that out of Oracle into something else? Well, AppDefend actually provides a solution for that type of logging out of the box to help you achieve PCI DSS compliance much quicker. Another area that's somewhat difficult for Oracle E-Business Suite, so requirement 8, is basically unique IDs are required for all access. Well, that becomes kind of difficult for E-Business Suite, so because your DBAs are going in as the apps account, as the sys account, all the time doing maintenance. PCI DSS is pretty stringent, even on administrator accounts. Generic accounts should not be used. So you need to have some mitigating controls in how those generic accounts are managed, where the password's stored. You should potentially have a password vault to store those generic accounts and allow checkout, things like that. Your DBA should be accessing the application routinely just to look at things with their own named accounts and only using the apps account when they absolutely have to, things like that. There's strong password controls. One interesting thing about PCI DSS is it requires very specific password controls. So most requirements out there are, well, you need to have strong passwords. No, PCI DSS says your length has to be equal to or greater than 7. Your failure limit has to be 6 or less. You have to expire passwords every 90 days. Your session timeout has to be 15 minutes. So those are all very settable in the Oracle E-Business Suite, but you have to enforce and verify that your organization's password controls are PCI DSS compliant and that you've set them correctly in the Oracle E-Business Suite. So just kind of the minor details. Another area that's kind of very interesting for PCI DSS is that it's very prescriptive on logging and monitoring. So it wants a detailed audit trail. And the reason it does is PCI DSS and the Security Council is very adamant about having logs and audit trails, because if there is an incident, if you have a data breach and you lose all your credit card numbers, they want to be able to come in and forensically figure out what happened when the incident occurred. How did people get in? What did they do? And unless you have very detailed logs, you can't do that. So they're very strong focus on trying to have an audit trail and have that audit trail protected and frequently reviewed. The requirement is daily review of critical logs. It doesn't say exactly what critical logs are, but too many failed password attempts pretty much fits into that requirement of having a critical log and have that reviewed on a daily basis and find out what's happening. The problem is within Oracle Business Suite is that there's a lot of generic accounts. When you access the application, everything is going on as the apps account. All batch traffic, all interactive user traffic, all the DBAs are doing their patching using apps. So you have to kind of split out that volume and try to figure out what's happening in the application and try to audit that, and also protect the audit trail. So if we map some of the Section 10 requirements specifically to Oracle Business Suite, so the first is they want to be able to take the audit trail and have an individual user who did it. So if someone used the apps account to access the application, what individual named user used that, especially when there's administrative privileges involved. Another requirement is all individual access to cardholder data. So anytime anyone selects cardholder data, they want an audit on that down to the individual person. That's a huge performance overhead. Very difficult to implement in an Oracle Business Suite environment. So your audit trail has to be very carefully designed. Another area is the secure audit trails. You cannot be doing a database audit trail to sysaud $. So you cannot be doing it to the database. It has to go to be somewhere where it can't be altered. Because the first thing someone's going to do is if they compromise your database, they're going to go back and delete the records from the audit trail most likely. And then you also have to retain the audit trail for at least a year. So that means getting the audit trail out of the Oracle Business Suite database into some other system. And typically that means you need to have an enterprise logging and auditing solution, either at the database level or just in general. A tool like Envision from RSA or ArcSight, Splunk is another good one. So here's an example of what we did for one of our clients in designing their audit trail. So we kind of mapped out what are some of the key events, mapped it to the PCI requirement, and then kind of estimated the volumes. Unfortunately, for most of the things, except for individual access to credit card data, most of the requirements are actually fairly easy. So you need at least all the sessions, all the failed logins. That shouldn't generate too much traffic in an Oracle Business Suite environment. And then most other things shouldn't be generating much at all. So you don't really create users that often and things like that. So an audit trail is very doable with the exception of all access to credit card data. And then the only other challenge is where do you put it? And you can use syslog. Oracle's database supports writing audit trail data to syslog, which then can immediately send that data with low performance overhead to an external logging solution. That's what we recommend for most of our clients. And kind of one of the final requirements is testing security on a regular basis. So there is a specific requirement that you actually do periodic penetration tests and security reviews, especially when you've got external facing applications. So if you have an internet facing module with Oracle like iSupplier, iStore, iSupport, iRecruitment, even though it's not accepting credit cards necessarily, you still have to be doing a penetration test because it's part of the application. Another interesting requirement that can be difficult to implement is that they require to deploy an file integrity monitoring software. So this is basically a tripwire. Anyone who's familiar with the tripwire product, those type of products basically sit and do a review of all files and tell you when a file is changed. The problem with an Oracle Business Suite environment is there's like 500,000 files. And so you're monitoring and trying to track and find changes in 500,000 files. So the challenge is trying to narrow that down. What changes, what's important. And one of the key important things is configuration files. So when you apply a patch, you may update hundreds of different files, but really your configuration files are probably some of the most important. Unfortunately for R12, they moved a lot of that data into the inst tab. So now the logs and the configuration files are pretty much centralized in one location. And you can set up Tripwire and or other products similar to monitor the instop and actually look through and say, okay, here's my instop, here's where the configuration files are in there, this is where the log files are. I don't care about the log files, I only care about any configuration files. And then when those files change, I need to somehow sample or on a periodic basis check that, yes, that configuration file was changed and here's a change ticket for the reason why it was actually changed. So again, PCI is very prescriptive, so it says you need a file integrity and monitoring software at the operating system level and try to track this type of information. So it's good and bad. There are some things that you say, well, does that really improve our security? I don't know, but that's the requirement if you want to be fully PCI DSS compliant. That's one of the things you have to deploy. And what will happen is if you do have a breach, the forensic auditors will come in and say, okay, the attacker got in via this hole in the operating system and then had to modify this configuration file. Were you monitoring that specific file? And if the answer was no, then basically full liability falls on you and you are not PCI DSS compliant. That's kind of how the process works overall, and that's why each requirement is important to satisfy. And there's a significant amount of policies and procedures also involved. So that was kind of a brief overview of PCI DSS compliance and the Oracle E-Business Suite. So I tried to highlight what are some of the key challenges that you'll achieve, what are some of the ways to satisfy it. Unfortunately, there's no easy answer. There's nothing to say, well, you just flip this switch, you flip that switch. Well, there's hundreds of switches you have to flip, and in order to do some things like scramble data, purge credit card data out of the environment, those require custom solutions because Oracle doesn't have everything out of the box today. The big positive, though, is the key requirement of encrypting credit card data. There is a patch available, and you should have that enabled. And then it's just kind of going through the requirements one by one. Integrigy has a current white paper out on our website that actually details this out. The white paper actually goes requirement by requirement. We did that a couple years ago. We're actually in the process of updating a new version that should be done hopefully at the end of August that will fully include PCI DSS 2.0. So again, look out for that. We'll actually probably send out an email to our mailing list when that gets updated. So I'll turn it back over to Phil to see if there's any questions.
Thank you, Steve. And yes, there are a couple of questions here. The first one, does the Oracle credit card encryption cause any performance problems?
Fortunately, the Oracle credit card encryption was fairly well designed, and so they do have some specific mechanisms in there to alleviate any potential performance problems. And the biggest performance problem would be searching, but they do store the credit card number both as an encrypted value and as a hash, and the hash is used purely for searching. Really, there should be no performance problem because what happens is you're only doing one credit card number at a time. Worst case scenario, you might be doing some batches, and so you're not doing that large number of credit cards at any one time. So if you're inserting a credit card or reading one credit card, typically most end user activity is one at a time, so there should be no performance overhead there. And the only time you might see a performance overhead is when you're actually going through and doing your payment batches, and it might be reading a couple hundred credit card numbers at a time, maybe 1,000. And fortunately, the overhead's pretty low. They've done a nice job. It's a pretty standard algorithm. It's using the standard Oracle database DBMS packages for encryption and decryption, so it works fairly well.
Okay. Next one. Is tokenization of credit card numbers supported?
So tokenization, for those on the call, is a way to basically get credit card numbers out of your environment. So the theory around tokenization is when I accept a credit card number, instead of actually keeping that true credit card number, I quickly process the credit card number but create what's called a token. So I've got a representation of that number that's not the actual credit card number, and I use that token throughout all my processing from then on. And there are a number of very good tokenization solutions out there. Unfortunately, Oracle does not support tokenization at this point. There is a full enhancement request to do tokenization. And the key is if you can do tokenization correctly, your Oracle E-Business Suite does not have to be PCI DSS compliant as long as the tokenization is done outside of the Oracle E-Business Suite. The problem with tokenization in E-Business Suite is depending on where you're processing refunds and chargebacks, you may actually need the real credit card number. And so it's kind of a challenge. Since Oracle doesn't natively support it, there are a number of third-party packages that do. And so one example of one package was when you actually have to enter the credit card number, it pops up a little box. And that box is not running your E-Business Suite, even though it pops up from the form or from the web page that you're supposed to enter a credit card number in the E-Business Suite. And it kind of intercepts the call, goes out to their website, and you actually type in the credit card number there. Then they return and insert into the Oracle E-Business Suite a token. So that basically eliminates PCI DSS compliance for E-Business Suite because that external provider has to be PCI DSS compliant, and the credit card number is never processed, never stored, or nothing ever happens in the E-Business Suite. Those solutions work okay. There's a lot of caveats to them. So we've had a couple cases where, yes, a client has been able to enable it and run successfully, but we've had a number of occasions where they have not been able to, just based on chargebacks, refunds, how they process internally. It's a major change to the way you do credit card processing. And if you can accept that, that's fine, but it's kind of I would look at it definitely as a solution, but think this probably won't work, but let's see if we can make it work. It's kind of the solution with tokenization. It's a great idea, it's a great concept, and hopefully Oracle Business Suite will support it in the future.
Okay, next question. What would be the method of extracting encrypted credit card data from a custom program as needed?
So in terms of, I think the question here is related to once the credit card numbers are actually in the Oracle Business Suite, it's encrypted. So if you actually have an interface that needs access to that data, Oracle does not publish the API to do that. What we've done in the past is that we've actually gone through and we've got the reverse engineering of the API. The API calls are in standard database packages, similar to FND Vault. There's 2 or 3 packages, both FND packages and IBY database packages that actually can access the credit card number as apps. So if you do have a custom program that needs to do that, first it needs to run as apps, because the way the encryption works, it can only run as apps. And then you just have to call those API calls, which are not published. They're fully available, but Oracle doesn't publish it or support it, so you do run the risk if Oracle changes that your custom program would break. But that's very doable. We've helped a number of our clients do that.
Next one. Do you have a regression test strategy when testing CPU releases for database applications, etc., to comply with a 30-day PCI requirement?
So our first pass at the CPU patches, especially in regard to PCI DSS, and you have to get them in very quickly, is to break them up. Your highest risk is at the database level. If you are going to get attacked, someone most likely is going to attempt to exploit a database security patch versus an Oracle Business Suite. And very seldom are the Oracle application server patches meaningful. Typically they're low-risk type items or not applicable to the Oracle Business Suite. So Integrigy standard patching methodology for Oracle Business Suite is apply the database patches as quickly as possible in a test or development environment and try to get those into production. We've got a few very large clients that do very little regression testing. They've had so few problems over time of actually bugs introduced or problems introduced. Very different than actually the patch not working. So yes, there's a very big problem about actually getting a good patch, getting it working, getting it installed, and actually having it apply cleanly. But very seldom are there ever a bug, especially in the last couple of years, that a database patch would break something. So we actually recommend that I think it's doable to get an Oracle Security Database patch in within 30 days. Apply it immediately into test and development, have it go through for a couple of weeks in those environments, and then get it applied to production with absolutely no functional regression testing or anything like that. The application patches are a different story because some of the patches have significant changes in them and may have an impact. So the way PCI DSS reads, you could probably come up and with a little bit of wiggle room and say, well, the database patches are our most critical, and then we reviewed, and based on a risk-based review of the e-business suite patch, so unless it's got something critical in iSupplier or one of the external modules, most likely would not have a significant impact to the environment, and you would then try to get it within maybe 90 days. And I think that would probably pass muster with most QSAs and most PCI audits. Occasionally there's some SQL injection bugs and other bugs, but again, if you run a mitigating control like Integrigy's App Defend product, we, within a few days of release of this critical patch update, release specific blocks to block e-business suite security vulnerabilities. So that would be a great mitigating control. So you could then say, okay, we got the database patch within 30 days. That is probably low risk and it probably wouldn't impact much. But then for the e-business suite environment, we have 90 days, but we do have a sufficient mitigating control like App Defend running both internally and externally would block any known vulnerabilities. Therefore, 90 days is sufficient for our organization. And that's how a typical mitigating control would work, is you need another very good level of control there to actually block the security patch issues. And that would be probably sufficient for most audits.
All right, next question. For our corporate credit cards, do we have to be PCI compliant?
This is actually an interesting question because we get it quite often. And the answer is almost always no. So your corporate credit cards, you own the liability. So if you lose those corporate credit cards, the liability falls on you anyways. Because the major problem with PCI compliance is that if a merchant loses credit cards, they want to push the liability off to the merchant from the credit card brand, because the credit card brand doesn't want to pay for reissuance of cards and things. For your corporate credit cards, you actually own the liability already. Therefore, they do not have to fall within PCI DSS compliance. Most people just ignore the topic and say that it's pretty clear, it's pretty straightforward, that you don't have to have corporate credit cards under that. The safe way to approach it is actually ask the issuer of those corporate credit cards, do we have to maintain PCI DSS compliance form? And every case I've ever had a client do that, and they got a note back very quickly from the issuer saying, nope, you do not have to be PCI DSS compliant for these. So the safe approach is just go to the issuer and ask them specifically, and they'll give you a note back on their stationery that says no, and then basically keep that for your compliance purposes.